Now, Chapter 2 Polynomials. Today we will do some questions from examination point of view. Before that, I would like to introduce one more small concept here. Like if I say that alpha and beta are the zeros of a quadratic polynomial, form the polynomial. Then there are two ways of doing this type of a question. If alpha and beta are the zeros of a quadratic polynomial, form the polynomial. How can I make the polynomial? First way, which we all know, is that the polynomial will be given by, the polynomial is x minus alpha, because alpha and beta are given to be the zeros. And as I told you, if I say x is equal to 3 is a zero of the given polynomial, then I say x minus 3 is a factor of that polynomial. In the same way, if I am saying x is equal to alpha is a zero of the given polynomial, then definitely x minus alpha will be a factor of the given polynomial. Similarly, as x is equal to beta is a zero of the given polynomial, so x minus beta is also a zero of the given polynomial. So, x minus beta is also a factor of the given polynomial. So, if x minus alpha and x minus beta are the factors of the given polynomial, we can express the polynomial like this: x minus alpha into x minus beta. And when I open out the bracket, I will get x square minus beta x minus alpha x plus alpha beta, or taking the common terms together, I will get x square minus alpha plus beta into x plus alpha into beta. This is one way of forming a polynomial when the zeros are given to us. Second method is directly by applying the formula. The formula is x square minus sum of the zeros into x plus product of the zeros. This is the direct formula which can be used for forming a quadratic polynomial when the zeros of a polynomial are given to us. So here alpha and beta are the zeros, so the polynomial formed will be x square minus sum of the zeros, which is alpha plus beta, into x plus product of the zeros, which is alpha into beta. Now these two polynomials are exactly the same. So we have two ways of forming a quadratic polynomial when the zeros of a polynomial are given to us. Now let us do some questions based on this concept. First question, I'll take it as: form a quadratic polynomial whose zeros are 3 plus minus root 5. Now what is the meaning of 3 plus minus root 5? It doesn't mean that the zeros are 3 and root 5. It means that the zeros are 3 plus root 5 and 3 minus root 5. Now when both the zeros are in the binomial form, it is better to use the second method which I told you just now of forming a quadratic polynomial. And what is the formula for that? X square minus sum of the zeros into x plus product of the zeros. Now we'll find out the sum of the zeros in this case. It is 3 plus root 5 plus 3 minus root 5. That will give you this, and this will get cancelled, and we are left with 6 here. And product of the zeros will be equal to 3 plus root 5 into 3 minus root 5. That gives you a square minus b square identity we are using. So 9 minus 5, that is equal to 4. Therefore the quadratic polynomial formed in this case is x square minus, now the sum of the zeros, that is coming out to be 6. So I'll write here 6 and then x plus product of the zeros, which is coming out to be 4. Hence the quadratic polynomial formed is x square minus 6x plus 4. Now the second one is the zeros are given to be 3 plus minus root 3 upon 5. That means the two zeros are One is 3 plus root 3 upon 5, the other is 3 minus root 3 upon 5. So now what is the sum of the zeros in this case? 3 plus root 3 upon 5 plus 3 minus root 3 upon 5, which will give you 3 plus root 3 plus 3 minus root 3 upon 5. We'll take 5 as the LCM. This and this will get cancelled and we're left with 6 by 5. Product of the zeros will be 3 plus root 5 upon 5 into 3 minus root 3, I'm so sorry, this is root 3 upon 5, which is equal to, again I'll use a plus b into a minus b for the numerator. 3 plus root 3 into 3 minus root 3 will give me a square minus b square, and the denominators will get multiplied. 5 into 5 is 25. That gives me 9 minus 3 upon 25, which is 6 upon 25. Therefore, by using the formula x square minus sum, which is equal to 6 by 5 into x plus the product 6 by 25. This is the required quadratic polynomial. Now here the next question is again forming a quadratic polynomial under different conditions. Sometimes the sum of the zeros is given and one of the zeros is given. Sometimes the product of the zeros and one of the zeros is given, and so on. So let's take them up one by one. The first part is find a quadratic polynomial. The moment you see this statement in a question, find a quadratic polynomial, in rough at least you can write down this, that x square minus sum of the zeros into x plus product of the zeros. So you are safe. You know that you know the sum of the zeros and the product of the zeros. Now read the question. It says one of the zeros is 7, and by default you can assume the two zeros of the given polynomial as alpha and beta. Here it is given one of the zeros is 7, the other one we don't know, and it is given product is equal to 28. So product is already there with us, we just need to find the sum of the zeros, and that we can find out only when we have the other zero. Now product of the two zeros is 28, means I can write alpha into beta is equal to 28. Alpha is given to be 7, 7 into beta is equal to 28, and this implies the other root beta is equal to 28 upon 7, which gives me 4. So the other zero is 4. So what is the sum of the zeros now? It is alpha plus beta is equal to 7 plus 4, which is equal to 11. So these are the two main things that we needed. One is the sum and the other is the product. So the quadratic polynomial formed is x square minus the sum, that is 11 into x, plus the product, which is 28. If you move step by step, the questions are not difficult at all. Second is find a quadratic polynomial. Again, what will I write? The moment I see this question, find a quadratic polynomial, so at least I can write down this statement immediately, in which one of the zeros is minus 5. So I'll write alpha is equal to minus 5, beta I do not know, and sum of the zeros is given to be 0. Sum of the zeros means alpha plus beta is equal to 0. If alpha is minus 5, then beta has to be equal to plus 5, only then the sum will come out to be 0. So now you have both the zeros with you, alpha is minus 5 and beta is 5. So what is the product of the zeros? Minus 5 into 5, that is minus 25. And hence the polynomial formed is x square minus sum was already given, product we have found. So 0 into x minus 25. So this implies x square minus 25 is the given quadratic polynomial formed. Next, the third part is again find the quadratic polynomial in which one zero is 12 and the product of the zeros is 0. One zero is 12, the other zero I do not know, but the product is equal to 0. That means alpha into beta is equal to 0. So 12 into beta is equal to 0 gives you beta also equal to 0. Orally also you can think about these things. Suppose if a question comes for 1 mark, you need not show the working and you can do it orally also. When the product of the zeros is given to be 0, and one of the zeros is 12, the other has to be 0, only then the product will come out to be 0. So in any case, if you have to show the working, you can show it like this. So beta is equal to 0. Now what is the sum of the zeros? That is alpha plus beta, 12 plus 0, and that is equal to 12. So the quadratic polynomial formed is x square minus 12x plus 0, or we can simply write x square minus 12x is the required quadratic polynomial. Next, fourth part is again the same, but let's do it once again. Alpha is equal to minus 13 and the sum of the zeros is minus 18. The other 0 I assume as beta. So in place of sum I am writing alpha plus beta is equal to minus 8. Now in place of alpha I can write minus 13 plus beta is equal to minus 18. So beta is minus 18 plus 13, which is equal to minus 5. So I have got beta as minus 5. And what do we have to form? The quadratic polynomial. So before that we need the product also. Product is equal to alpha into beta, which is minus 13 into minus 5, which is equal to 65. And hence the polynomial formed is x square minus sum of the zeros, which is given to be minus 18. Please look at the minus signs very carefully. X square minus, by default this minus sign has to be there. Now the sum is minus 18, so that I have put inside the bracket, minus 18 into x plus the product, which is 65. So finally the answer will be x square plus 18x plus 65. Now I'll just discuss the other two parts orally. Sum of the zeros is given to be 0 and the product of the zeros is given to be minus 17. So can we very quickly form the polynomial in this case? X square minus the sum is 0, so 0x plus, but the product is minus 17, so I can say x square minus 17 is the polynomial in the fifth part. Now in the sixth part, sum is minus 2, product is minus 35. So x square minus is anyway there by default, and then the sum is minus 2, so I'll write it in the bracket, into x plus product, which is minus 35. So I'll get x square plus 2x minus 35 is the required polynomial. Now next, question number 3 says, if one of the zeros of the quadratic polynomial, the given quadratic polynomial is this, one of the zeros is given to be minus 3, then find the value of k. Now understand one thing, like whenever you read a question, you should be able to see that question from all the angles. Here it is given one of the zeros is given to us, and that is the only thing given to us in the question and nothing else. Okay, we could have used sum of the zeros and product of the zeros, but here missing term k is there, so that is also of no use writing down the sum and the product. So we will use the basic definition of the zero of a polynomial. The basic definition is, if I say x is equal to 2 is a zero of the polynomial x square minus 4x plus 4, this polynomial. In that case, I will say that if I put the value x equal to 2 in the given polynomial, it should reduce to 0. The same thing here, if it is given to us that x is equal to minus 3 is a zero of the given polynomial, it means when I put minus 3 in the given polynomial, its value should reduce to 0. So applying that condition, you will be able to find the value of k. So I'll assume this polynomial as, say, px. Let px be the polynomial. The first thing you should do in the polynomials questions is to name the polynomial. Then you can say, as x is equal to minus 3 is a zero of the given polynomial px. Therefore, when I put x equal to 3 in the given polynomial, means p of minus 3, then what should happen? Then its value should reduce to 0, and this is by the definition of zero of a polynomial. I hope you understand this concept. So when I open up the bracket, I'll get 9 into k minus 1 minus 3k plus 1 equal to 0, and when you open it out, 9k minus 9 minus 3k plus 1 equal to 0, 6k minus 8 equal to 0, so k is equal to 8 upon 6, which gives you 4 by 3. That is the value of k in this question. Now read the next question, question number 4. If one of the zeros of the quadratic polynomial this is 1 by 3, find the other zero. What is the difference in the previous question and this question? There also it was given one of the zeros of the quadratic polynomial is minus 3. Here also the given part is the same. One of the zeros of the quadratic polynomial is 1 by 3. But if you look at the polynomial of the above question, here the coefficients are missing numbers like k, k minus 1 and so on. Whereas in this polynomial, the coefficients are very much given in the question. Okay, so here we can use alpha plus beta and alpha into beta that we have studied. Find the other zero. So what do we assume? Let alpha and beta are the zeros of the given quadratic polynomial. Okay, these are the zeros. Now one of the zeros is already given, say 1 by 3, and beta we have to find out. So now when alpha and beta are the zeros, the moment you write this statement alpha and beta are the zeros of the given polynomial, then you know what is the sum of the zeros given by? Sum of the zeros is given by the formula minus b upon a, and the product of the zeros is given by the formula c upon a. For that it is very important to find out what is a, b and c in the given polynomial. Here a is equal to 3, b is equal to minus 10 and c is equal to 3. So alpha plus beta, can I write it as 1 by 3 plus beta is equal to minus b upon a, that will ultimately come out to be 10 by 3. Now coming to question number 5, it says if the zeros of the polynomial 5x square minus 7x plus k are the reciprocals of each other, then find the value of k. Let me first write down the polynomial 5x square minus 7x plus k. Now whenever you have to deal with the zeros of a given quadratic polynomial, first of all let us assume the zeros. Now in this case, okay, before assuming the zeros, let me just write what is a, b and c. A is 5, b is minus 7 and c is k in this case. Now what is given about the zeros of this polynomial? It is given the zeros are the reciprocals of each other. So instead of assuming the zeros as alpha and beta, can I say let alpha and 1 upon alpha are the zeros of the given polynomial, because it is very clearly written that they are the reciprocals of each other. Reciprocal means the opposite. So what do we write here? Sum of the zeros is alpha plus 1 upon alpha, which is equal to minus b upon a. Now minus of minus 7 upon 5, that is 7 upon 5. Then we write down the product, which is alpha into 1 upon alpha, which is equal to c upon a, that is equal to k upon 5. Now if I just look at the second expression, here LHS is alpha into 1 upon alpha, it gets cancelled and we are left with 1 on the left hand side, and on the right hand side I have k upon 5. So I will get k is equal to 5. So the moment you see that the reciprocals, the zeros are the reciprocals of each other, immediately you can say the product is equal to 1. In that case we need not use this concept of sum. I just wrote it for you to understand that why I am writing both of them, but ultimately it is not required. The only thing which is required is the product in this case, because the zeros are reciprocals, and reciprocal means when you multiply them the product will be 1. So this is the most important step you have to remember. Look at the polynomial and find out the product by the method c upon a and put it equal to 1, and you will get the value of k. Question number 6. If the zeros of the polynomial x square minus px plus q are double in value to the zeros of this polynomial 2x square minus 5x minus 3, Then find P and Q. So here the question says that zeros of this polynomial are double in value to the zeros of this polynomial. So we'll start by saying let alpha and beta are the zeros of this polynomial 2x square minus 5x minus 3. Now the question says that the zero of this polynomial are double in value to the zeros of this. So I can say, and let 2 alpha and 2 beta are the zeros of another polynomial which is x square minus px plus q. You just need to get this statement with you and then you can form two equations out of it. If alpha and beta are the zeros of this, I can simply write sum of the zeros as minus b upon a, product of the zeros as c upon a. The question is what is minus b upon a? For that you must know here a is equal to 2, b is equal to minus 5 and c is equal to minus 3. So minus b upon a will be minus of minus 5 upon 2, that is 5 by 2, and c upon a will be minus 3 upon 2. This is there with us. Now using the second one, 2 alpha and 2 beta are the zeros of this polynomial. So again sum of the zeros 2 alpha plus 2 beta is equal to minus b upon a. And what is that equal to? In this case a is equal to 1, b is equal to minus p and c is equal to q. So I'll get minus of minus p upon 1, that is equal to p. And now if you look at it carefully, if I take 2 common from here, alpha plus beta is left inside the bracket. And now what is alpha plus beta from here? It is 5 by 2. So twice of 5 by 2 is equal to p. That means p is equal to 5. Similarly, after making this sum, I can make another equation with product also. 2 alpha into 2 beta is equal to c upon a. That means 4 alpha beta is equal to q upon 1. And now what is the value of alpha beta? That is minus 3 by 2. So 4 into minus 3 by 2 is equal to q, and that will be minus 6. Q is equal to minus 6. P is equal to 5 and Q is equal to minus 6. So basically when you read the question, you just understand the question and remember the main steps to be followed in the question. Next, question number 7 is, what is the value of p for which the polynomial this is exactly divisible by x minus 2? Now what does it mean when I say this polynomial is exactly divisible by x minus 2? This means that x minus 2 is a factor of the given polynomial. If I name it as px, so it is a factor, and this implies that x is equal to 2 is a 0 of the given polynomial px. That means if I put x is equal to 2 in the entire polynomial, its value should reduce to 0. That means p of 2 should be equal to 0. So if I put x equal to 2 everywhere, I'll get 2 cube plus 4 into 2 square minus p into 2 plus 8 is equal to 0. So 8 plus 16 minus 2p plus 8 is equal to 0, and this implies 32 is equal to 2p, and so p is equal to 16. So we have got the value of p like this. Question number 8. If one of the zeros of the polynomial this is negative of the other. Now I think in question number 5 we did reciprocal of each other. When the two zeros are reciprocal of each other, then we immediately say that the product of the zeros will be 1. And here when we say the zeros are negative of each other, it means if I have to take the zeros as alpha and minus alpha are the zeros of the given polynomial. So if alpha and minus alpha are the zeros of the given polynomial, what will happen to their sum? Alpha plus minus alpha will reduce to 0. It means if the zeros are negative of each other, then you simply put sum equal to 0. Now what is sum equal to? Minus b by a, that should be equal to 0. That is minus k by 4 is equal to 0, or k is equal to 4. Right? Similarly, question number 9th. If the zeros of the polynomial x square plus px plus q are 3 and 2, find the values of p and q. So again, zeros of this polynomial are 3 and 2. For these type of statements, what do we use? We simply say that sum of the zeros, this is the polynomial, so here a will be 1, b will be p, and c would be q. Okay, find the values of p and q. Now we'll say sum of the zeros is given by the formula minus b upon a. Now in place of sum, can I write 3 plus 2 is equal to minus b by a, that is minus p upon 1. So that gives you minus 5 is equal to p. Right. Similarly, q you can find out by using product. Product is equal to c by a. What is the product given to us here? 3 into 2 is equal to q upon 1. That means 6 is equal to q. Q is equal to 6 and p is equal to minus 5. Now question number 10 says, if alpha and beta are the zeros of this polynomial such that alpha minus beta is equal to 1, find the value of k. See, what we have to find, that will automatically come. Basically, we have to concentrate on what is given to us. Again, the same statement, if alpha and beta are the zeros of this polynomial. So what will I write? Alpha plus beta is equal to minus b upon a. And minus b upon a will find out from the polynomial itself. In the polynomial, I am just writing the polynomial here. This is the polynomial. Here a is equal to 1, b is equal to minus 5, and c is equal to k. So minus b upon a will be 5. And alpha into beta is equal to c upon a, which is equal to k upon 1. Now you have always been given alpha minus beta is equal to 1. So you have two equations with you. One is that alpha plus beta is equal to 5. Another is alpha minus beta is equal to 1. So if I solve them, I'll get 2 alpha is equal to 6 or alpha is equal to 3. And once I put alpha equal to 3 in the above equation, I will get beta is equal to 5 minus 3. So beta is equal to 2. Alpha and beta we have got, but we have to find out the value of k. So this was the expression which was left unused. So we can use this expression now. Alpha into beta is equal to k. So 3 into 2 is equal to k. That means 6 is equal to k. So the value of k in this case will be equal to 6.